This question is asked in Gate 22 of Electronics. This is from digital subjects and from the combinational circuit topic to a very specific multiplexer based question. The question is, consider 2-bit multiplexers shown in the figure. For output to be the XOR of C and D, the value for A0, A1, A2 and A3 are. Okay, so what the question is telling is we want this output should be C XOR D, right? So it is for output to be XOR of C and D. That means we need the output to be C XOR D. So what are the value of A0, A1, A2 and A3? So so if I ask you to write the output expressions, so output expression in this case will be C bar D bar A0 plus C bar D A1 plus CD bar A2 plus CD and A3. By the way, what is the C XOR D? C XOR D, C bar D plus CD bar. So if you compare, C bar D is present in this term, CD bar is present in this term. So we need these terms and we don't need this term, we don't need this term. Okay, that means what I'll be doing is definitely A0 equals to 0. I'll be taking A1 equals to 1 so that this overall term is now become C bar D. So if I'm making A0 equal to 0, so this term is 0. So 0 and this is C bar D. Again, I'll be making this A2 value 1. If I make A2 value 1, so I'll be getting this is CD bar and I'll make this A3 value 0. If I make A3 value 0, then this term is again 0. So the output is equals to basically C bar D plus CD bar. Okay, this is what we need. So what are the things we have done? So for A0, it is 0, A1 1, A2 1 and A3 0. So the pattern is 0 1 1 0. So 0 1 1 0, this is not the options. This is also not the option. 0 1 1 0, this is present. This is answer. And anyway, D is also not correct. So answer is C. So very simple and straightforward questions. You need hardly 10 to 15 seconds to answer this. Answer is option C. This question is asked in EC Gate 22. This is from digital subjects and from Boolean algebra topic. The question is, select the Boolean functions equivalent to x plus yz, where x, y and z are Boolean variables and plus denotes the logical OR operation. So by observing this term function in the bracket s, so there is a possibility that it can be MSQ question. That means more than one options can be correct. So basically we have the function x plus yz and we have to check which of the four options which are being given here. Okay, so that is equivalent to x plus yz. So we have to check these all options. So let us go one by one. So if I go with option A, so option A is saying the function value is x plus z plus xy. So let me take x common from the first and the last term. So this is 1 plus y and then this is plus z. So 1 plus y is what? 1 only. So this is basically x plus z. But my requirement is x plus yz. But what we are getting? We are getting x plus z. So A is not the right answer. So I'm putting a cross in A. So let us try with B. So if I try with B, so in B the function is given x plus y with x plus z. X plus z. So this is a very standard thing. So directly you can say x plus yz. Otherwise, x ANDed with x is x. X ANDed with z is xz. Then y ANDed with x is xy and y ANDed with z is yz. So from the first three term, if I take x common, it is 1 plus z plus y and this is yz. And 1 plus something is 1. So this is equivalent to, of course, x plus yz. So our requirement is x plus yz and this is option B is giving me x plus yz. So yes, B is one of the right options. So let us verify C and D as well. If I go with C, so the function value is given x plus xy plus yz. So from the first two term, I can take x common. This is 1 plus y and this is yz. So 1 plus y is 1. So this is equivalent to x plus yz. So yes, my requirement is x plus yz. So C is also coming correct. But what about option D? So D, if I check, so the function value is x plus xz plus xy. If I take x common from all of it, so it is 1 plus z plus y. So 1 plus something is 1. This is x. But my requirement is x plus yz. So this is not satisfying. So B and C are the right option for this. So answer is option B and C. It's MSQ question, so no surprise, more than one option can be correct. This question is asked in Gate 22 of ECE. This is from digital subjects and from the sequential circuit topic. The question is, for the circuit zone, the clock frequency is F0 and the duty cycle is 25%. For the signal at the Q output of the flip-flop is dash. The options, if you see, frequency is F0 by 4, duty cycle is 50. Frequency F0 by 4, duty cycle is 25%. Frequency F0 by 2, duty cycle is 50%. Frequency F0, duty cycle is 25%. Basically, what we are supposed to get, if you observe the options, so what is this frequency and what is the duty cycle of this waveform? So we have to get the frequency and the duty cycle of this waveform. Okay, what is the data given? That this is a 2-bit counter. Okay, and its LSB is connected to a JK flip-flop where both J and K are sorted. Okay, so how do you proceed? So 2-bit binary counter, so the counting pattern is not given. If it is not given, so by default we'll be going by the sequence 0001 1011. So let me note, this is my A1 and this is my A0. So the counting sequence of the this 2-bit binary counter, that is A1 A0. So the sequence will be by default assuming 0001 1011. Okay, it can be any other sequence, but if no data is given, so we are assuming it's a 2-bit binary up counters with this sequence. Okay, fine. So now, if you observe, this A0 is connected to the JK input. So if I ask you, so what is the input to the JK flip-flop? So here J equals to K and this equals to A0. So if I concentrate A0, so A0 is, this is your A0, 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 A0. That means when the clocks will be triggered, so at A0 terminal, first you will get 0, then you will get 1, then you will get 0, then you will get 1. That means this JK flip-flop will receive the input 0, 1, 0, 1 and again 0, 1, 0, 1 and so on and so forth. This is the sequence that this JK flip-flop will receive the inputs. And again by default we are assuming the initial condition of this JK flip-flop Q equal to 0. Okay, Q equal to 0. So we'll see. So here I am writing here like this. Initially, okay, your Q equals to 0. Okay. So when you give the first clock, what is the input? So initially the first input is 0 only, right? So if the input is 0, so the input is 0 now. Now I am about to apply the first clock. So if I give the first clock, the input is 0. So what is the property of JK flip-flop? The property of JK flip-flop is it will maintain the previous state. If you remember, for the JK flip-flop, okay, so what it says, like if the input is 0, 0, so your Q plus value equals to Q. If the input is 1, 1, your Q plus value equals to Q bar. We need only these two sequences in this problem because J and K are sorted. Their value can be both 0, 0, it can be both 1, 1. So when the A0 value is 0, that is J and K both are 0. Now if you give the first clock, so it will maintain the previous state. So the previous state we have assume it is 0. So this is maintaining 0. Okay, now what is the input to the JK input now again? So first clock is over. Now I am about to apply the second clock. So in the influence of second clock, okay, so what the input to this JK flip-flop? The input is nothing but equals to 1. Okay, so if the input is 1, so what is the next state of this JK flip-flop? So next state will be complement of the previous state, that is your Q plus equals to 1. Yes or no? So when you are giving the second clock, so at A0 you are getting this 1. So this 1 you are getting here, and when this 1 is received by the JK flip-flop, the property says if both are 1, 1, Q plus equals to Q bar. So the previous state is 0, so the complement of that is basically 1. Okay, so two clocks are over. Now when the third clock is given, the input to this JK, okay, this will be basically this 0. So here you will get 0. So if I give the third clock, so the counter is producing 0, and if the 0 is given to JK flip-flop, it will again maintain its previous state. So previous state is Q plus equals to Q. So Q is basically 1 in the previous case we got, so the same one will be maintained. Okay, now third clock are over. So fourth clock, if I speak, so at the fourth clock, the A0 will be 1. So if A0 is 1, Q plus is again Q complements. So Q is basically 1. So Q complement is basically 0. Yes or no? That means if you start applying the clock 1, 2, 3, 4, 1, 2, 3, 4 in that sequence, so in the next state, you are again going to get 0, 1, 1, 0, 0, 1, 1, 0, this pattern. Okay. So let us draw the waveform of Q, which will give us some more clarity. Okay. So for that, so what I'm doing is, you see here, what is being given? The clock frequency is F0 and the duty cycle is 25%. So on period is less than the off period. Otherwise, if it is equal case, it would have been 50%. So let me draw a couple of cycle. First cycle, second cycle, third cycle, fourth cycle, fifth cycle. Okay, like this. So this is your first, this is your second, this is your third, this is your fourth, fifth, sixth, and so on and so forth. So, okay, so what I'll be plotting? So I'll be plotting, this is what, nothing but your clock. And this clock having frequency F0 given. So now I'll be plotting the waveform Q. So Q initial state is 0. So initially it is 0. So I'm putting here 0. Now when the first clock is received, the Q plus is 0. So on the influence of the first clock, it is 0. So this 0 will be continued till the next clock. So this is 0. Now when the second clock is given, your Q plus is 1. So on the influence of the second clock, so now which was 0, so this will change to 1. So this 1 will be continued till the next clock comes. So Q plus is 0, then Q plus is 1. So 2 clocks are over. Now when the third is applied, your Q plus equals to 1. So this 1 will be continued like this. So third is over, right? Now when the fourth is coming, your Q plus is basically 0. So here it will again drop like this. And this is your 0. Then what is going to happen? Then if you keep on applying the clock, so that means if you continue to apply this 5th clock cycle, 6th clock cycle, 7th clock cycle, and so on and so forth, what's going to happen? So 0, 1, 1, 0 was the pattern. Okay. So now what will happen then? So again, so this will be 0 here, because the same cycle again repeat. What was happening in first, same thing happened on 5th. What was happening on second, the same thing happened on 6th. So at second it is 1. So 6th, this will be, again it is 1. That means what is happening on first, it will happen on 5th. Second will happen on 6th. So again, for your interest, if I say 7th, so what was happening in third, so it will again maintain. And what is happening in 8th, so the whatever happening in 4th, it will be happening here. So Q plus equals to 0. So just for sake of, explaining, I'm just drawing this. So the pattern is 0, 1, 1, 0. So here again, it is what? 0, 1, 1, 0 is over. Then one more cycle, 0. Then again, it will be 1 and so on and so forth, like this. So this is the waveform Q. So if I ask you, what is the period of this one? So if I concentrate this particular segment, what is the period? So if you see, like how many clock this is covering. So this is covering 1 clock. I mean, this is what 1 clock. This is what is the second clock. Then this is the third clock. And this is the fourth clock. So basically, time period of Q is nothing but equals to 4 time T clock. Or 1 cycle of Q is covering 4 clock cycle. So but what we are supposed to find? We are supposed to find the frequency. So what is the frequency? So frequency of Q is nothing but equals to 1 by TQ, which is 1 by 4 T clock. So 1 by T clock is F0 here. That means frequency of clock is given F0. So this is F0 by 4. So the frequency of the Q terminal is F0 by 4. So if you observe the options, so F0 by 4 is given in the first 2 options. So C and D are anywhere wrong. But next again, you have to decide what is the duty cycle, 50% or 25%. So what do you think? What is the duty cycle? So if I ask you whether this width and this width are same or different, the widths are same. The on period and the off period, I mean the duration interval for what it is 1 and for what it is 0, both are same. If the interval are same, the duty cycle is definitely 50%. So no matter, even if the clock duty cycle is 10% or whatever you take it, so with respect to duty cycle, it doesn't matter in this case, right? So the duty cycle of Q will be, naturally it is 50% only. So the frequency is F0 by 4 and the duty cycle is 50%, which is given in option A. So let me summarize again what I did in this case. So firstly, I have taken the counting sequence of the counter is 0001 1011. That means when the clocks will be triggered. So in the and we are assuming the ideal devices. There is no delay on this. So if the first clock is applied, so at A naught will be getting 0. When the second clock will be applied, at A naught will be getting 1. When the third will be applied, it will be getting 0. And when the fourth will be applied, it will be getting 1. And these are the same thing will be reflected on the input of the JK. So when JK is receiving 0, it will maintain the previous state, that is 0. When JK is receiving 1, 1, it will complement the previous state. So 0 complement is 1. In the third clock, you are again giving 0. So it will again maintain the previous state, it is 1. And in the fourth clock, what is happening? You are again giving 1. So complement of the previous state is 0. So basic JK flip-flop characteristic table you should have idea. And by taking these all information, if I am plotting with respect to clock waveform, the Q waveform I am getting something like this. And if I am comparing with the clock waveform, so the period of this is coming 4t clock and the frequency is f0 by 4. And the duty cycle is coming 50%. So yeah, this is somewhat a good question you can say. Not tough one, but yes, a little bit logic you need. So the answer is A for this. f0 by 4 the frequency and duty cycle is 50%. This question is asked in gate 22 of ECE. This is from digital subjects and from finite state machine or sequencer circuit topic you may say. The question is a state transition diagram with state ABC and transition probabilities P1, P2, P7 is shown in the figure. Example, P1 denotes probability of transition from A to B. For this state diagram, select the statements which are universally true. So by observing the word statements are, it's a clue to you like this can be MSQ questions, right? So more than one option can be correct. Okay, so let's say if I ask you what is the meaning of this line where P4 is written, it means if the present state is A, the next state will be C, its probability is P4. What is the meaning of this line? If the present state is B, the next state will be again B, the probability is P2. What is the meaning of P6? It means if the present state is C, the next state will be A, its probability is P6. That's what it means, the meaning of this line. So now let us concentrate on state A. So from state A, how many arrows are outgoing or how many are coming to the same A? Because that's what will decide if the present state is A, what is the next state. So from A, if I concentrate, so from A, the next state can be B with probability P1, which is outgoing. Next state can be C with probability P4. Next state can be again A with probability P7. That means if the present state is A, so the next state can be B, okay. Next state can be C, next state can be A, right? So what is the probability if the present state is A, the next state is B? Okay, so that is nothing but your P1. So this probability is P1. If the present state is A, the next state is C, the probability is P4. If the present state is A, next state is again A, the probability is P7. And it is confirmed, like because there are three states A, B and C. If the present state is A, so the next state can be either of A, B, C. So definitely I can tell from here that P1 plus P4 plus P7, so this is definitely equals to 1. Yes or no? This is definitely equals to 1 because this is something like a sample space. If I ask you, if I'm tossing a coin, what is the probability that the output will be either head or tail? What is the answer? It is 1. Or if I'm rolling a dice, what is the probability that the output will be between 1 to 6? Answer is 1. It's something like this. Because there are only three states, A, B and C. If you are at a state A, the possibility is it can stay at A, it can go to B or it can go to C. If I'm asking you if the present state is A, what is the probability that it can go to either A or B or C? Answer is definitely 1 because we are including all possibilities. So this is for, A, we have said this. In the same logic, if the present state is B, okay, so where it is going? So if I check this way, if the present state is B, next state is again B with probability P2. So next state is again B with probability P2. So if the present state is B, the next state can be A, okay, with probability P3, And from B to C, we don't have anything, right? You don't see any arrow from B to C kind of thing. So it's not there. So that means from B, there are two possibilities. So it can go to either B or it can go to either A. So definitely So what is the sum of this probability P2 plus P3 equals to 1? Right? Because from B, there are two possibilities. Okay. So that is, it can go to either A or it can stay at the same state B. So if I ask you what is the probability that if the present state is A, the next state can be the same B or it is A, the answer is definitely 1. In the same logic, so for C, if I check again in this diagram, so the next state can be again C with probability P5, or the next state can be A with probability P6. So that means if I ask you, so what is P5 plus P6? This is again 1, right? So basically what I have done is, so I went to a particular node, and in that node I am checking what are the possibility, and then I am asking you what is the probability that all these possibility are possible. The answer is 1 definitely. So if I check the options, P1 plus P4 plus P7 equals to 1. So this is given in option C. So C is correct. Next is P2 plus P3 is 1 here, and P5 plus P6 is 1 here. So 1 equals to 1. So I can tell P2 plus P3, which is 1, is equals to P5 plus P6. Their numeric values are same. So P2 plus P3 equals to P5 plus P6. This is also correct. Okay. Now, so this is what we concluded from this. Now also let us check the remaining options. Let's say I am checking the D. D is saying P2 plus P5 plus P7 equals to 1. Okay. So what is P2 plus P5 plus P7? P2 is where? This is your P2. And P5 is this one, and P7 is this one. That means if you see, so if the present state is something, what is the probability that the next state will be again the same state? So in general they are asking. Because what are the numeric values of P1, P2 up to P7 we don't know, we cannot say what is this. So let's say some of you may say, sir, if we take it is equiprobable cases, that means all the probability are same. So, in that case you may say, yeah, this is correct, this can be correct. But we don't know. Let's say for example, here in the first case we said P1 plus P4 plus P7 equals to 1. In the equal probable cases, you can say, okay, fine, if I add all of this, it will be, 1. But if it is unequal probable cases, sum of P1 plus P4 plus P7 will be 1, but they are not necessarily to be same individually. That means P1 plus P4 plus P7 equals to 1, but it doesn't mean that P1 equals to P4 equals to P7. Okay, that is not necessarily to be true, because there is no information regarding probability. So we cannot say like P2 plus P5 plus P7 equals to true, because here also one important term is used universally. That means what? In all cases. All cases, in other words, equiprobable cases and non-equiprobable cases. So if it is non-equiprobable cases, then definitely, unless until you don't know what is the individual probability, how do you say it? You cannot say. So definitely option D is wrong. What about option B? Option B, what option B is saying? Option B is saying P1 plus P3, P1, this one, plus P3, this one, is equals to P4 plus P6. Again the same story. Again the same story. Unless until we don't know what is their individual probability, how do you say? We cannot say. So universally, we cannot say these are true by defaults. So definitely based on this, the answer is, it is A and C. It's MSQ questions. The question is looking complicated, but it is not that complicated. If you use your common sense, you should be able to tell the answer. Yes, some of students, by default, if you might have taken it is equiprobable cases. In that case, all will be correct then, if you think that way. Like if somebody give the conditions that probability of P1, P4, P7, they are same. Probability of P2, P3 are same. Like that, if they say, all of this, then there might be cases. But here, because of the term universal, you cannot say what that is exactly. So the answer is A and C for this. This question is asked in Gate 22 of EC. This is from digital subjects and from logic gate topic. The question is, consider a Boolean gate D where the output Y is related to the input A and B as Y equals to A plus B bar, where plus denotes logical OR operation. The Boolean input 0 and 1 are also available separately. Using instances of only D gates and input 0 and 1, select the correct options. If you see the options like NAND gates can be implemented, or logic cannot be implemented, nor can be implemented, and cannot be implemented. So basically we have a gate D whose output is A plus B bar. We have to check using this gate which of the gates can be implemented, which cannot be implemented. Okay. So this kind of question has been asked in Gate 2015 of electronics. The same question they have just asked again by changing the language. Okay, so there they have asked which of the gate is universal logic gate, like that they have asked. So same question they have asked again. Okay, so how is the gate then? So if I ask you to draw it, so this is something like this. So it's a bubble gate, all right? So this is your A, this is your B. So this is your output Y, this is your A plus B bar. This is what is the gate D is. Now let me show you one by one. Suppose I ask you to design a NOT gate. So I'm going with NOT because NAND NOR gate. So is again, like you need a NOT gate there, right? Discussion of NOT will come into picture. So let me first show you how to design the NOT gate, and then we'll go into the other gates. So here it is clearly said the inputs 0 and 1 are available separately. So that means to design the gates, you may use the signal 0 and 1. That is a by default assumption also. Even if it would not have been given, we would have taken that way. So what I'm doing is, so the first signal A, let me make it 0, and this I'm making it B. Okay, so if I ask you what are the outputs, so 0 plus B bar, so this is becoming Y equals to B bar. So this is equivalent to a NOT gate, because if I have a NOT gate, if I give the input B, I get the output B bar. So this is equivalent to your NOT gate. So using this, we have designed the NOT gate. So D NOT we have designed. Some of you may say, sir, okay, you have generated B bar. Is it possible to generate A bar? Why not? So how do you get it then? So the logic is very simple. You you do one thing. This is your A, and this is what is the terminal where bubble is present. So let's make this is 1. So what do you get? So 1 complement is 0, 0 plus A, this is your A. Then you can connect it to the same gate, okay, with A here, and this is your 0. Okay, so this is your A bar plus 0. So this is your A bar. So whether you want to generate B bar or A bar, no problem. So NOT gate we have designed. So NOT gate we have designed. So this logic gate D, so this can work like a NOT gate. There is no doubt about it. Now let us see what are the possibility of the other gates, right? So let's do one thing. So this is done. Now what I'm doing is, so see here carefully how I'm designing. Now let me show you how do you design the NAND gates. So NAND gate, so NAND gate is given by AB whole complement, which is equivalent to A bar plus B bar by De Morgan's law. So I'll be showing you now how we are implementing this. So I'll be showing you A bar plus B bar. That is of course logically equivalent to AB whole complements. So first I'll be generating A bar. So what we'll be doing is this gate I'll be taking. This gate I'll be taking, right? So I need A bar. So here I am giving you 0. Here I am giving you A. So what is the output of this? You get A bar. You got A bar. Then what do you do then? So then you need A bar plus B bar, right? So here I'm again taking the gate same, one more time. This is the gate D. This is the gate D. These are all the same gate D, right? So this is A bar, and here I'm giving B. So what is the output Y you will get? You will get this is A bar plus B bar, which is of course equivalent to AB whole complements. And this is nothing but the NAND gates. That means, so this gate is equivalent to NAND gates, like because the output is AB whole complement. So this is equivalent to the NAND gates. So this is A, this is B, this is AB complement. So NAND gate we have designed. So earlier we have designed the what? The NOT gate. So now we have designed the NAND gate. So D NAND we have implemented. Now once you got this, once you got this NAND gates, isn't it possible to get the AND gate? Yes, because we have already seen NOT gate is possible. The output of NAND, if I pass through a NOT gate, so what do you get? You get AND gate. So that means, so suppose if I explain you here, it is something like this. So NAND gate output we have. So what I'm doing is, now I'm passing this through the one more D gates, and this I'm making it 0. So what do you get? You get complement of these inputs, which is your Y is equals to AB. So this is nothing but your NAND gates. So AND gates, right? So D AND also we have designed. Okay, so if you see, NAND logic can be implemented. So yes, this is correct. Then AND logic cannot be implemented. So we have implemented AND gates. So D is wrong. Now we have to check the option B and see what they will be. Okay. So let me now show you the design of NOR gate first. And once I have NOR gate, again in the same logic, I can go with the OR gate by putting a NOT gate there, right? So for that, so what I'm doing is NOR gate. So NOR gate output is A plus B whole complements. So my idea will be, first I'll be generating A plus B, and then we'll be taking its these things to get this thing. So what I can do is, so let me take the D gate. So this is your A, this is your 1. So 1 complement is 0, 0 plus A is A. So here you got A. Next, so here again I'm taking the D gates. This is your B. Yeah, you take this is your B, and this is your 0, right? So what do you get? You got here, this is your B bar. Okay, so you got this is B bar, right? Then what you do is, again you take a D gates. Okay, so here if I put a bubble like this, so what is the output of this? So this is your A plus B. So that means what gate this is? So this is nothing but your OR gate. You have the OR gate. Once you have the OR gate, you again connect one more D gate with bubble with to A plus B. So this is 0, and if you take this one, so this is coming A plus B whole complement. So this output is basically NOR. So we have design OR and we have design NOR. So what is given? OR logic cannot be implemented. OR can be implemented. NOR logic can be implemented. Yes, NOR logic can be implemented. So the correct options are A and C. In fact, in the theory, you must have learned the concept of functional completeness, right? In the functional completeness, so this y is equals to AB bar and y is equals to A plus B bar. So these are functionally completed. They are standard informations. Functional complete means you can design any gates. I mean, it works like kind of a universal gates. So I was just showing you illustration one by one, but otherwise students who have solved that gate 2015 question, so immediately you can put the options A and C, because it's a universal case, everything can be designed. So cannot option directly you can eliminate, can be you can pick it up. So this is your NOT gate, this is your NAND, this is AND, this is your OR, this is your NOR. Okay, and once you have these all other gates like XOR, XNOR, so which are combination of this AND or NOT, you can easily design. So the answer is A and C for this.